Okay, we're going to work on going from factored form of a quadratic to the vertex form of a quadratic. Here's our factored form. Let's write f at x is equal to, and we use letters to represent these numbers here. This is called our factored form, and we want to go to vertex form. It's very common to tell a student that to go from factor to vertex, you need to go to standard, and these are the three real types of forms we use. Standard, and that's the one I'm going to quickly write here in black. Y equals ax squared plus bx plus c. Do you recall that one at all? Yeah. When factoring, you kind of go from standard to factored. So anyways, a lot of times it'll be said to go factor to standard, which in order to do that, you have to expand. Okay, so you expand. And then to go from standard to vertex, you do something called completing the square, which is a difficult process. Completing I'm just going to draw a square, okay? Completing the square. And it's a difficult process, and you haven't learned it yet. But there's another way you can do this, as long as you understand the forms of the equations, okay? So we have to understand, first of all, what these brackets represent. And these brackets will help us, and this is why we use factor form, find x-intercepts. In fact, your r and your s, okay, so if we're drawing a parabola here, like this, these are your r and your s. They're your x-intercepts, s and this is r, and it doesn't matter which one you call which, okay? So let's figure out how these values really help us out. Now you notice there's a number in front of x, so this value isn't exactly your r and your s. The best way to do this is remember that an x-intercept is when your y value is equal to 0. So f at x is essentially our y value. So we're going to replace f at x with 0. Okay, 0 is equal to 2x minus 1, and then x minus 4. I don't like that. So we set it equal to 0, like we said. And when you set something equal to 0, these brackets essentially mean a number. They represent a term, like say maybe it was term z times term w. In order to multiply two numbers together and get a 0, one of them must be 0, because there are no two numbers or any other number that gives you a 0 when multiplying. So with that idea, what we're going to do is we're going to test for both. What if the first set of brackets is 0, so we say 0 is equal to 2x minus 1? And what if the second set of brackets, I'll just use a different color, is 0. 0 equals x minus 4, okay? And what we'll do there is we'll isolate for the x in both of these situations to find out the two possible answers. That means there's two answers to this question. The one on the right is the easiest. When I bring negative 4 to the other side, do you know what it becomes?
Positive.
Yeah, so x is positive 4. That's one of our x-intercepts. And the other one, I bring negative 1 to the other side, it becomes positive 1, but this is still 2x. And in order to get x by itself, I have to divide by 2. So this becomes a half, or 0.5 is equal to x. So these are our two x-intercepts in this case. Okay. So if we were to draw this, we have one x-intercept at the number 4, and the other one at a half. Okay. Here's a quick question. Do you know if this parabola opens upwards or downwards? Looking at this.
Up.
Up. How do you know that?
Because the a value would be 1.
That's right. The a value is 1. That's really good that you recognize what the a value is. So we have a parabola that does this. Okay. Now, what this has done is helped us find two x-intercepts. Okay. We also want to know the vertex. In fact, to go from factor to the vertex form is important. Vertex form tells us what the vertex is. But instead of doing this complicated step called completing the square, we can just work with our x-intercepts. What we can look for is something called the axis of symmetry. In the axis of symmetry, they call it AOS, is equal to the two x values, so x1 plus x2, your two x-intercepts, divided by 2. This is also the x value of the vertex, okay? So any line that runs right through the middle is essentially the x value of our vertex. Let's write that a little nicer here, okay? So we're going to use our axis of symmetry equation. So they call this the AOS. So our axis of symmetry, well, we take our two values. AOS is equal to 1/2 plus 4 divided by 2. I'll change that to a decimal so it's easier to work with. It's 0.5. And 4 plus 0.5 is 4.5. You okay with that?
Mm-hmm.
Divided by 2. When I divide by 2, I'm going to get 2.25. So the x value of our vertex, we've already figured this out, is 2.25. Beautiful. Now the y value. What is the y value of a vertex? There's a couple ways we can do this. One of the simplest ways to do it is to take our factored form, and since we now know the x value, plug it in for our x's and solve for our y. So let's do it that way. Since that's the most common way to do it, there are formulas, but we'll do this. So f at x, which is our y, is equal to 2x minus 1, and x, I believe it was minus 4. Let me just double check. Yes, that's right. Okay, so we're going to take this value and we're going to replace x in both these situations since this is the x value. And we get 2 times 2.25 minus 1. So we got to be good with our bed mass here. And then 2.25 minus 4. Okay. I'm going to get a calculator to help me out here. This should be 4.5 minus 1. Just double check. Sometimes I make mistakes. And this should be a negative 1.75. I believe. Was that perfect right?
Yeah.
Okay, so this becomes 3.5 times negative 1.75. Is that second
Yeah.
part right?
Yeah.
Okay. I know that's right. Can you do the multiplication there? Because that's going to be something a little more difficult for me to do in my head. I know it'll be negative. Maybe 5 something. Maybe even 6.
Negative
1.75. 6.12. So negative 6.125.
Mm-hmm.
Great. So that's the y value. And I should have done this in blue because I wanted to relate to something. And this will do in green, negative 6.125. Okay. So I found the vertex. And in order to go to vertex form being y equals f at x is equal to a x minus h squared plus k, right? Well, the h and the k are represented by the x and y of our vertex. The x of our vertex and the y are essentially the h and the k value. And for us, we just figured out that they were 2.25 and negative 6.125. So I can replace k with this value. I can replace h with this value. Let's do that. A, still unknown, but we'll talk about how easy it is to find that. Subtract, our h value is positive. So because we subtract a positive value, it's going to look like a negative 2.25. Okay. If you recall from transforming equations, that's very intuitive what we mean. And our k value is negative 6.125. And finally, our a value. How do we know our a value? Well, our a value in every form that we use, factor, vertex, or even standard, is always the same. So in this one, it was the value of 1. So our a value is 1 is equal to x minus 2.25 squared minus 6.125. And just to show this idea, I'm going to bring it up. Okay, finally our a value. Now, though easy, it is a little tricky. We got to take our factored form here. Okay, so we're going to do it as like a side calculation. F at x is equal to 2x minus 1, x minus 4. In order to have the same a value every time, because our factored form is usually written as a x minus r, x minus s, if you notice in this version, the x's both have a coefficient of 1. It's important that in our factored form, to have the true a value, we have to make sure they have coefficients of 1. So this guy has a coefficient of 1. Great, I don't have to factor anything out. This one has a coefficient of 2. So I have to factor out the value of 2. I could have done this right off the bat. I stuck to this starting out the other way just because that's how we normally do it. But let's factor out 2. So I got to divide both of these values by 2. Okay. When I do that, 2 is on the outside. Nothing wrong with this. This becomes x. Negative 1 divided by 2 is negative 0.5 or negative 1/2, which is essentially how I wrote it. Okay, and x minus 4. If you remember, our x-intercepts were positive 4 and positive 1/2. When looking at it this way, it's really easy to see our x-intercepts, okay? It was a little harder in this version because we had a coefficient in front of 2. Once we factor that out, that is our a value, that number 2. So that number 2, y equals 2. And then we still have our x minus 2.25. Should have wrote that in blue. Minus 6.125. Okay. So let's take a look. I've plugged them into a graphing calculator, and our 2, they end up overlapping each other perfectly, right? They both have the same x-intercepts at 0.5 and 0.4. And here's our vertex form. Our vertex having a y value of negative 6.125 and an x value of positive 2.25. And even if I write our factored form with our new way of our 2 outside the brackets, we have x minus 1 over 2, okay, and then x minus 4, and look at that. It's just another way to write it. As I turn them off, they're all the exact same thing, okay? So this and this are equivalent factored systems. We just got, we factored out so that our x values have coefficients of 1, so we know what our true a value is. And that helps us with our vertex form, okay? So a lot of steps, but might be potentially easier than completing the square. Depends on how you see it.